diode load. Okay. So what we'll be learning for today is going to be common source amplifier with diode load. So the content for today's class is common source amplifier. How do you make a diode load? Okay, so we will see how to make a load as a diode and what are the disadvantages of resistive load, right? Then how is a diode load applied to a common source amplifier? Okay, so the diode load we are going to construct using PMOS as well as NMOS. So what happens when you apply PMOS as a diode load? How will the amplifier produce the gain? That will be looking. And similarly NMOS. Okay, then we'll have the inference of diode load and we'll see a small problem how to construct a diode load using the common source amplifier. Okay, this is the content flow for today's class. So we'll start up with what is the disadvantages of a resistive load. Okay, now what is the disadvantage of resistive load? Can anybody tell why is that? What is the disadvantage when we go for resistor in chip designing? How many of you have studied this paper called VLSI? Can you please raise your hands? How many of you have studied this paper called VLSI? Isaac has studied. Only one, two, three. VLSI paper. Not all of you, eh? Sounds strange. Shaik, you're not studied?
No, sir.
No. Francis?
No, sir.
No. Okay. Mantino? Mantino, you're not studied? Mantino, are you there? No, sir. Okay. Ashwin was also not studied. I hope so. Okay, that's okay. Fine. That's not a problem. Thank you. You can drop your hands now. Now, when you look at resistors, when you drop it into an IC, okay, the disadvantage is resistor occupies a large area. Okay, the area is almost like one transistor size it will occupy, more than one transistor size. Okay, so sorry, one chip size, not transistor size, one chip size. All of you have seen a resistor, right? You have seen a chip. Sometimes it occupies the size of that, and it's very difficult to replace that. Okay, we definitely need a load. All of you know we need a load resistance for a common source amplifier in order to make it functionally fit for any application, right? So what they decided is they went into use these CMOS amplifiers, CMOS MOS circuits to a amplifier as loads. Okay. Now, what is the difference between a transistor and diode? What is the difference between a transistor and a diode? Can I have Mr. Yeah. Joel? Joel, what is the difference between a transistor and diode? Joel, a difference between a transistor and a diode. Terminals. How many terminals are there in? Good, that's the right answer, Joel. How many terminals are there in transistor? How many are there in diode? Yeah, 3 in which one? 3 in which one? Obviously in transistor, right? So we need to make a transistor into a diode. Now what we have to do, if you want to make a transistor into a diode, you have to make it into two-terminal device. Okay, so you need to make it to a two-terminal device. Now how do you make it? That's what we'll be learning now. Okay, now how do you make a transistor into a two-terminal device? Look at the figure in the left. You see this is what type of device is this? This is a PMOS, right? So this PMOS has to be made into a diode. So what do they do is they short the gate and the drain. Okay, they short means that there are only two leads for this device. One is drain, the other one is the source. Okay, similarly the gate and drain is shorted for NMOS. This is NMOS. Okay, and this is PMOS now. Okay, now how do you convert a transistor into a diode? and they ask you, please remember, they short the two terminals. Is that clear? So this is how you make a transistor into a diode. Is that clear, all of you? So they might ask you, how do you make? So you short the two terminals and you make it into a diode, right? It perfectly works like a diode. You don't consider any body effect. Okay, the resistance of the device is given to be, there is a resistance of the transistor which is given as 1 by gm. 1 by gm is equal to resistance. All of you, are you clear with that? How do you get 1 by gm? It is 1 by gm is r naught. Okay, r naught means rm of a transistor. Okay, so this is the resistance, this in parallel with r naught. Okay, r naught is the internal resistance of the transistor. So that is the total resistance without body effect. Okay, so similarly for this thing, the other way you can make is, you can short these two terminals and ground it. Okay, means that your bulk is coming into play. Okay, the body effect is coming into play. If your body effect is coming into play, there will be a resistance because of this grounding. Okay, or the substrate. So that resistance is given to be gm mb. Okay, mb means bulk. Okay, so because of the bulk, there is a transconductance effect. So that value gets added in series with the transconductance of the transistor. Okay, so the total resistance is, when you don't take channel length modulation into account, it will be gm 1 bus gm by, this r naught is negated. Okay, r naught is the internal resistance. So when lambda is made equal to 0, these two are resistors are negated, and you get the resistance to be this. Okay, so this is how you make a transistor into a diode. Is that clear, all of you? Okay, so you short the two terminals and make it into a diode, right? So now we'll go to the next part. There are two type of transistors you have. Okay, one is PMOS, the other one is NMOS. Okay, so both these two are made into a diode in this way. Okay, generally PMOS will not have any body effect. Can you tell why? Why does a PMOS generally don't have a body effect? Or can we ask Isaac? Isaac, why does a PMOS don't have a body effect? Generally, why? Isaac? Isaac, are you
Sir?
there?
Yes, sir.
Isaac, why do you have no body effect in the PMOS generally?
Uh, so because of the less mobility of holes and therefore the depletion region is a little more difficult to form. So I'm not sure.
Hmm, mobility is not the factor now. Generally, where does the PMOS comes in a CMOS circuit?
Oh, in the CMOS circuits at the top,
Huh? PMOS.
sir,
Where does PMOS come?
uh, as a pull-up circuit, sir.
In a CMOS circuit, where does the PMOS come?
As a pull-up circuit, sir, at the top.
At the top. So there is
Yes,
no body effect coming into play, right?
yes, sir.
There's no substrate connected, so there is no much of body effect generally. Okay, and that's why the sentence is given there, no body effect, right? And when it comes to NMOS, you generally take into account, right? So that's how these two. This is how you use a NMOS and PMOS. This is NMOS. This is PMOS. When the arrow is coming out, it is NMOS. Okay, and if the arrow is going in, I think hopefully all of you know, it's a PMOS, right? So now we are going to use, instead of that resistor, we are going to use the diode as a load. Okay, that's what we are dealing with. Okay, so today's class, what we have seen is we have seen how to construct a CMOS, a CS amplifier, common source amplifier as diode load. We saw how to make a diode into a resistor, and then how do you make a transistor into a diode and use that as a resistance. So the resistance value is Gm 1 by Gm. If you take the body effect into consideration, it is Gm plus GMB. Okay, and then we saw how to make a CMOS as a diode and NMOS as a diode. Okay, so now we are going to apply this diode in the resistive load of a common source amplifier. Okay, so how do you do that? This is the resistance. This is the place where you draw your resistance, right? Instead of that, you draw the diode. Okay, so instead of the resistance, you are drawing the diode. So diode is nothing but this PMOS. This PMOS, they are just replacing it over here. Is that clear, all of you? So the remaining terms are all same. You have V in, V out. This is a common source amplifier. Instead of the resistive load, we are replacing it as diode load. Now, why we are replacing it? You can reduce the size almost 1 by trillion times smaller. That's what they say. Okay, so you can make the size to be so small when you put a simple diode with transistor, right? So that's why we go into make it. Now, when you make it, obviously the gain is going to vary. Generally, it is given by minus Gm into R naught, right? But in this case, the gain, because of the normal transistor, that is M1, okay, is given to be minus Gm. So minus Gm is not going to vary. Only the R naught is going to vary. Okay, the R naught here is given as Rx. Rx is the resistance, and R naught is the resistance, internal resistance of the first transistor. Okay, so this Rx, what is this Rx? Rx is given to be Gm2 into Gm2 is this transistor's transconductance in parallel with R0. R0 is the internal resistance of M2, and R01 is the internal resistance of the first transistor M. Is that clear, all of you? So this R0 is give Rx is nothing but the resistance of the second transistor. This is Rx. Okay, this is the Rx value, and this Rx value is given to be 1 by Gm2 in parallel with R0 2. Okay, and then this is in parallel with R0. So is the shift in gain clear for everybody? Okay, so that is the gain of a diode connected load. Can I have a response? All of you got the point clear? Can you please raise your hands if you got it? Thank you, Francis. The rest of you, Lurai got it. Shika, Adyan, Mantino. Mantino, did you get it, ma? You want me to explain once again? I'll do it. Ashwin, Shri Ashwin Raja. Got the point clear? Ashwin Raja. Joel, is that okay? Joel Livingston. Can you repeat? Okay. Now, what is the gain of an amplifier? It is V out by V in, right? Generally, what is the gain of an amplifier, Joel? What is the gain of an amplifier? Joel, what is the gain of an amplifier? Normal amplifier. Minus Gm into RD, right? Now, minus Gm is fine. The RD is alone vary, right? Now, there are two RDs here. One is you have a normal resistance, that is Rx. Generally, okay, and that is parallel with this internal resistance. This internal resistance is given to be R01. Okay, the resistance of this transistor is given to be R01. That is the resistance of this first transistor. So both are in parallel because there is an output here. It's not in series. So both are in parallel. Is that clear? So Rx in parallel with R01. That's what is written over here. And then what do you have? You have the next value. The next value is GM1. What is this Rx? This Rx is nothing but the internal resistance into 1 by GM. 1 by GM is nothing but the resistance of this transistor M2. Okay, that is a large signal. That's a normal transconductance. Transconductance 1 by GM is nothing but the resistance of the transistor. And this is the small signal gain or resistance, internal resistance of this second transistor, parallel with this R0. Is that clear? Sir, R0 is neglected. Do we need to take them into account? No, R0 is not neglected. R0 is taken into consideration. Okay. The reason capital RD we neglect is because RD is a very high value. But here R0 is going to be a very small value. So R0 has to be taken into consideration. Okay. Generally, when you take RD, it will be in ohms, but here it will be in micro ohms. So you need to take both into consideration. Then only you'll get the perfect gain of the amplifier. Okay. Fine. So I hope all of you got that particular point clear. And then we need to find out what is the gain, ignoring the channel length modulation. Okay, so R0, R01. I'm just negating it. I don't want all these big values. I just want to calculate what is the gain. Okay, just Pakka tell me what is the gain of the transistor with respect to resistor. How do you find out? I'm just neglecting this. Joel, your question is answered here. Yes, Ahatyan, can you go ahead? What do you want? Ahatyan, you raise your hand. Okay, 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 it's okay. Now, when you look at what is the gain in general, it is very simple. What is it? Minus GM into 1 by GM2. Is that clear? So that's the general gain. We neglect all these things. Just remove it. Okay. Now, what is the general expression? This is equal to minus GM into GM2. Is that clear, all of you? So general gain is minus GM1 into GM2. Okay. Now you have to write what is GM. GM is root of 2 mu n COX W by L into ID divided by, please look at this terminology, 2 mu n. Okay, mu n is the mobility of, what is the GM1? This is NMOS transistor. Okay, mu np is PMOS transistor. That is the only difference. You have to be very careful. And the next terminology is the width and length, the aspect ratio. That's called the aspect ratio of the transistor. So aspect ratio is given as W by L. So W by L of 1 divided by W by L of 2 into ID1 into ID2. Okay, when I make the other things constants, I can make it. This COX and COX gets cancelled. I1 is made equal to I2. The current can be made equal. So these two gets cancelled. So your general expression is of your gain is determined on mu n mobility of P. Okay, this is, and then W well by W2. So this is the general gain for a diode when it is PMOS, right? So is that clear, all of you? Now, the last thing before we go, we have got 1 more minute. So what do we do? The last thing is the gain can otherwise be expressed as like this. This is expression wise. This is the transistor sizing. The gain can be expressed as GM is equal to I by V. All of you know the formula, right? A transconductance is I by V. We looked at last class. So which factor of I it depends is 2 times ID divided by VGS minus VDH. Okay, this is for the PMOS, NMOS transistor. This is for the PMOS transistor. Okay. ID1 is made equal to ID2. So these two gets cancelled. ID1 is made equal to ID2. So these two get cancelled. So what happens here is you get the voltage is equal to VGS2 minus VTH and VGS1 minus VTH. Okay, IDS2 made equal to IDS to get this particular expression. Is that clear, all of you? With that, I'll stop for today's class. To sum up what we have learned today, we've seen the analysis of common source amplifier with respect to diode. We saw how to make a diode from a transistor, that is by short circuiting. Now, the first analysis is we are doing PMOS diode load with respect to the resistor load. Okay, so we replace it, find out the gain. So the gain analysis can be done with respect to channel length modulation as well as with respect to the voltage. So this is how you get the gain. With that, I'll stop. All right. Thank you, Ma. Hopefully everything is clear for you. In case you have any doubts, you can ask in the WhatsApp group also. I think all of you are present, right? Joel? 2, 4, 5, 6, 7, 9. Right. Thank you, Ma. You can let. Please complete your assignment and post it in the Google Classroom.
Thank you, sir.
Thank you, Ma. Bye. Take care.